In this video, let me see how do you change the driver board for the elevators or lift. So to explain this one, we have taken the example at a Vignan college. So why you have taken the example as a Vignan college means one day early morning 5 o'clock due to the high voltage the driver board was burned as well as the braking shoes for the lift also. So we have to replace that old driver board with a new driver board as well as a braking shoe. So let me start with a just briefing about the general operation of a elevator or the lift. Here we have seen the cabin. This is nothing but car. The passengers will be staying in the cabin to move from one floor to the another floor. At the top of the cabin, through the hook, wire is tagged to this cabin that is wounded around the pulley. Other side of the tag means that is GA tag. The other side of the GA tag is connected to the counterweight. That pulley will be driven by the motor. Here, what type of motor we use it for this elevator means three-phase induction motor we use. Now come to the different modes of operation of the lift. Forward motoring. During the forward motoring, this cabin will be coming from the top to the bottom. Suppose if any passenger is coming from the top to the nothing but a fourth floor to the first floor or ground floor means then the motor should be operated in a forward motoring. While traveling, if you want to stop in any floor means then you have to apply the braking. That is nothing but a braking in a forward motoring. Reverse motoring. Reverse motoring means when the motor is running in a reverse direction, this cabin will be moving from the ground floor to the up floor. The same manner, if you want to stop that motor in a particular floor means then again you have to apply the braking. So in this manner we can able to operate the motor in four modes of operation. One is forward motoring, braking, reverse motoring as well as the braking, so that this cabin will be moving from the top to the bottom or bottom to top as well as we can apply the braking also. Next, how we are going to moving this cabin means by means of a motor. We use the motor as a three-phase induction motor. The power rating is 7.5 HP motor, 400 volts, 50 Hz. The running speed is a 1500 RPM. Variable voltage, variable frequency motor. This motor is designed such a way that we can operate as a at a variable voltage as well as a variable frequency so that we can maintain the VBF ratio as a constant during the forward motoring as well as the reverse motoring. This is the driver board which is giving a pulses to the inverter circuit. That inverter circuit will be giving a variable voltage and variable frequency to the induction motor so that how much speed the motor has to maintain while the lift is moving from the one floor to the another floor. Now here we are going to observe the from this four terminal we are going to give connection to the three-phase induction motor where the stator winding is connected in a star. That's why here the neutral terminal also there. So these four terminals we have to give connection to the RYB neutral. The same manner here three terminals are there along with the neutral. So these three terminals you have to give connection to the three-phase supply. Now remaining some connections also should be given to this driver motor. Then only it can give the pulses to the inverter. See here you can see these pins. These pins and these pins and these pins are we are going to connect to the microcontroller which are connected to the sensors. So in our lift also we have seen the sensors at a entering point. Nothing but when the person is entering into the cabin, the door should not be closed. The same manner, we are simply pressing the first floor and second floor, third floor. How do you know the mission means? By means of the sensors only. That signal will be goes to the microcontroller. That microcontroller will be giving a or signal to the driver circuit. The driver circuit will be taking a decision and giving a appropriate pulses to the inverter. That inverter circuit will be giving a variable voltage and frequency to the induction motor. In that manner, it will be running and stopping at a particular and a desired floor which is selected by the passengers. In next coming video, we are going to see how do you replace that driver board as well as the braking shoes for the elevator which is at a Vignan college. Because this is the new driver board. This new driver board they are going to fix on the board by means of bolt and nut because they are going to fix in a old place. These are the braking shoes. Yeah, braking shoes are nothing but a resistors only. Those braking shoes they are simply connecting and placing in a old place because the braking shoes also damaged for the lift. They are going to replace both braking shoes as well as the driver board to the lift at a time. You can see in the video how they are going to set that all braking shoes. The two braking shoes are there. Next, you can see separately the old one as well as the new one. Driver board. This is the old driver board. This is the new driver board. Next, they are fixing the driver board. This is the braking shoe, old braking shoe. This one is the old braking shoe. So first they are fixing that new driver board on the board by means of drilling machine. They kept some hose. Through the hose they are fixing the new driver board to the board by means of a bolt and nut. Again they are going to keep that driver board in a old place only. Now they are giving a connection to the motor as well as a supply and a microcontroller sensors. So to perfect operating of this driver board. So already I have seen all these connections in a previously. Next, we are going to test this new driver board whether it is working perfectly or not. So whenever we replace this new driver board, the lift is going very fastly, and while it is stopping very less amount of time. Again, we informed to the technician so that he was rectified that problem. He simply changed the settings in this driver board, nothing but a control block, which decrease the speed of a induction motor during the running as well as the stopping also. So remaining wires which are coming from the microcontroller which is fixed aside of this board. Not only running the motor, it has to take a lot of decision so that the microcontroller is placed. Now we are going to test that driver board whether it is working or not. Let we see. Now the motor is running. So previously because of the damage of the driver board due to the high voltage, it is stopped nearly the 10 days. Now we are replacing that old driver board to the by new driver board. Again this lift is come to the running condition. We checked everything, speed during the running as well as stopping also. Everything is working perfectly. Now how to avoid this high voltage damage of these lifts and any sensitive equipment means? By means of such protection device also we can protect these sensitive loads.